Hey guys, and welcome back to another YouTube video. This is gonna be an awesome video where I'm gonna be teaching you how you can create your own autoencoder using Python and TensorFlow. This is gonna be a pretty cool tutorial. We are gonna be generating artwork using autoencoders. So this is gonna be a pretty cool video. Now, one thing that I just wanted to say is that this is something that it's not something for like beginners or something like that. I would recommend that you have a little more understanding in how machine learning and all of this stuff works before you even jump into this video. So yeah, that's just something that I wanted to tell you. Now, one thing that I've seen is there are a lot of autoencoder videos on YouTube, but all of them, they use like the fashion MNIST dataset or the MNIST dataset, and I didn't want to do that. I wanted to use something different, so I'm going to be doing it with artwork. We're going to be dealing with custom data. Now, I'm going to be using Kaggle's notebooks instead of like downloading the dataset, because I don't want to download it basically because this is a pretty big data set. It's like as you can see, it's a very big data set, and I actually cannot download it because like I can obviously, but I don't want to download such a huge thing, so that's why. So I'm just gonna rename this to art, I don't know, artwork generator. So we're gonna be generating artwork, but before we even get started on what how to use these autoencoders, we're gonna be having a very simple example. How do these things work? What exactly are they? So I actually had found a really cool article on Kaggle that kind of have this little diagram that I really seem to like. Basically, you have a bunch of inputs, you have a bunch of hidden layers, and you take those hidden layers and you take your input. Now, first of all, before we even look at the hidden layers, I actually forgot to mention this, but autoencoders is an unsupervised algorithm. So yeah, so basically what you have is you have a bunch of inputs, then you have a bunch of hidden layers. Now what the hidden layers will do is they will try to kind of map the inputs and create a few patterns, and then you will have this latent view representation, which basically will be like basically this is going to be like the most, like the least resolution and the least kind of the latent view representation will only contain the things that like the model kind of understood through the picture, and how it would kind of represent the picture in like a very very low kind of resolution or something like that. Then you have h1 prime and h2 prime and x1 x2 x3. Basically, now what the decoder does is it forgets everything that the encoder ever did, and then it will look at the only thing that was left by the dense layer, this one, and will try to create that same thing using that latent view representation. So yeah, that's basically what we're going to do. Alright, so let's just get started. Now I'm going to be using TensorFlow for this video. You can use anything that you want, it is up to you. So we're gonna having a few imports for this. So first import TensorFlow as TF, then we can just say from TensorFlow import keras. We're gonna need numpy, so import numpy as np from matplotlib. Matplotlib import pyplot as plt, and we're also gonna need from TensorFlow dot keras dot what was it, pre-processing dot image import image data generator. Alright, cool. Just a second, let me just see if I have imported everything that I need. Alright, I think we have done everything. Alright, cool. So we can just run this, no errors, perfect. So now let's just define the train image and the train data set. So we can just say train image is equals to the image data generator, and you can just use the rescale property and rescale, and we can then just do 1 divided by 255.0. This should convert every single value of between a range of 0 to 1, because neural networks can better predict if the stuff lies in that range. So that's why you probably want to do this. So once we have done that, we can just run that. Now comes the part where people usually get a little finicky or they don't understand, because the thing is, a lot of these things, videos that I've seen, basically they use like custom like Keras data sets. And if you are good at data loading, data processing, you probably could easily figure out how to load in custom data. But if you are not that great at it and you have just started out with networks, it can be very intimidating on how you can actually load in custom data. So now I'm going to show you exactly how to do it. It's very simple if you do it like that. So first we can just define the training data set, which is going to be the train image dot flow from directory. Alright, and now what you want to do is you want to pass in the directory path in there. Now we don't want to get the images, we actually want to get the resized. The reason why we want to do that, because we don't want to have these subdirectories inside each of these. We don't need them, and so we can just get rid of it. What we do need is this. So what we're gonna do is we are gonna get the best artworks of all time. So first of all, we just get we're gonna need this file path. So we can just pass in this, and we're going to be passing in a few different parameters. So we're going to be passing the target size, and I'm going to be having it at 200 by 200, and I think we're also going to specify a batch size, and I'm just going to specify it at 100. Alright, cool. So now we can just do that, and that should hopefully load up our training data set, hopefully. Now I actually want to check, does Kaggle provide us with like a GPU, because that would be a lot better, because I really don't wanna do this off of like that. Can we get that? Accelerator, perfect. We want a GPU. Turning on GPU will reduce the number of CPUs available and will only speed up image processing and neural networks. Availability is blah 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 blah. Turn on GPU. That's what we want. Alright, cool. Now that we have a GPU, this should actually do stuff a lot better. I was actually finding a GPU before I started out with this video, but just the amount of time that it took us to load up that data, I kind of got an idea that it would take a whole lot of time to actually process it, via a neural network. So I just thought, let's just go ahead and do this. Alright, so I think we're gonna have to run all of this stuff again, because at least in Google Colab, if you do change your runtime type, then you gotta run the things again. Alright, cool. So now we have a trained data set, but currently we have a little bit of an issue with our training data set, because right now if I actually get the type of our training data set, you will see what the issue is. Now the issue is that it is actually of type directory iterator. Now the thing is, Keras data set, for very simple kind of classification tasks, you could just use this and go along with it, but you can't in the case of autoencoders. You gotta convert all of this into a NumPy format. Hence, we actually imported NumPy over here, because we gotta convert this to NumPy format. How do we do that? It's actually very simple. Now I actually did not write this code. This code was actually written by someone on Stack Overflow, because it's just one line, but it is not something that you would probably expect. So I'm literally copying it from here. So we just use np.concatenate. I am hoping I do not mess up the spelling. Alright, so then you can just provide the train data set, and you just say .next, and then you can just say 0 for I in range train underscore a set dot underscore len. Alright, done. This should actually convert this to NumPy format. I don't know what it does really, but Stack Overflow suggested it, and I literally copy pasted this piece of code. Alright, so currently we do have it in numpy format. Now just to be a little sure, the way I'm gonna do it is I'm gonna take this entire data set and I'm gonna convert it into a floating point format. Now there is just one issue. As you can see, it's taking a whole lot of time to even run this piece of code, mainly because we are working with 8,000 images, and I feel like the GPU and stuff that we have over here, it only works for the model. So I feel like we shouldn't have done this, because now you're gonna be using a whole lot of CPU. Alright, so we have 2 minutes, 3.7 GB. So as you can see, this is taking up a whole lot of CPU space, also a pretty good amount of RAM. It's a good thing that I'm not training this on my machine, or I don't know what it would be doing right now. Alright, so I think we can continue writing on with the code, but like a lot of our stuff will be dependent on this line of code, so I can't really continue a lot, but I think we can write a few lines. So we can then just say xtrain is equals to xtrain dot as type, and we can just convert it into a floating point 32. So pretty simple. Holy, it's taking a whole lot of time. Alright, it's finally done. Yay. Cool. Oh, come on, I hope it doesn't take so much of time to do this same thing. Alright, cool. This was fast. Alright, so now if I go ahead and just print out the xtrain, not interested. So if I just print out the xtrain, so the first thing that you're gonna see is all of these values are between 0 and 1, and that's exactly what we want, because we had divided them by 255. Also, one more thing, my RAM is filling up. Alright, so that is exactly what we wanted. So since we are getting that, that is awesome. Alright, so now what we want to do is we want to first get the shape of our data. So I can just get the xtrain.shape really quickly. You want to book right, blah 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 blah. Are you kidding me? Are you kidding? Oh my goodness. Alright, train dataset dot length, and alright, we can just do train dataset dot length minus, I don't know, like 3000. We're gonna have to do something like that, because I cannot just bro, I seriously, man, I didn't want to run this stuff again. I mean, it's good that I'm not running this off of my local machine, because I mean, I don't even think it could survive something like this. Alright, need at least one array to concatenate. What do you mean by that? Well, all I'm saying is that I want to subtract 3000 from the length. Wait a second, I'm gonna have to print out the length again over here. Print train dataset .shape, print train dataset .length. Oops, I'm sorry, I've been doing a lot of like Java and Dart lately, so yeah. Alright, directory data has no attribute shape. Got it, done. 87. We just have one class. Oh, I guess I know what it's trying to say. If I do that, 2, what the hell do you mean by 2? What if I do that? 100. If I do that, 200. Oh, I guess I gonna get the way that they are doing it. Wait a second, let me see how they have actually kind of arranged the train data set, because I don't want a whole lot of that stuff. Wait, I can't print out the train data set. That is not good. Bro, I thought we could print that stuff out. Alright, well, okay, so how exactly can we do this? Um, okay, I think one way we could do it is, alright, like, this is like a GPU issue, this is not like a neural net issue, so I'm not very good at solving stuff like that. Alright, but how exactly can we do that? So like one way I would go ahead and do it would be like maybe, because I can't exactly get rid of any of these directories, they aren't giving me any option to do that, so I don't know if we can even do something like that. And I cannot load in the entire thing, so that's a bigger issue. Wait, so if I do that sorry for that, if I do that, alright, so this is kind of crazy because it's like, okay, this is really crazy the way that they have formatted this data. I think I actually got it. I actually think I got exactly how they've done it, because it kind of matches the shape of the data. Alright, so I think I think I kind of got it. So basically I think the way I'm gonna have to do it is something like this: 0, and I'm gonna have to subtract, I don't know, like 100. God damn it. Alright, so this is gonna take up like a whole lot of CPU. Can I get any more RAM on this thing? Review session metrics. Because I need to get a lot of RAM, and I'm gonna need a whole lot of RAM for this. As you can see, the RAM session thing it is filling up pretty fast. The CPU is already, a whole lot of CPU is being used. GPU, we still haven't even reached the GPU section yet. I think I shouldn't have turned it on, because even running this line of code, like, I get it, because this is a larger data set, and I think Kaggle isn't providing like a better GPU, because I have never used Kaggle before. This is my first time using Kaggle for like an actual neural net task. So I didn't know how this would go. But the first thing that I can see is that the RAM thing is starting to fill up a lot. As you can see, out of a 13 gigabyte we already have filled up on 4.9 gigabytes. That's not great, because all we have done now is just this much. So like, we could, like, initially I thought maybe we could shorten up code, but I don't think we can really do any of that right now. So yeah. Alright, so let's try running this. Let's just hope that it doesn't take up a whole lot of RAM to do stuff like that. Alright, I'm not gonna waste like RAM. This is the first time I'm doing something like that. Alright, so we have the shape. Cool. I don't know why we filled up on RAM initially then. I don't know. Alright, cool. So we have the shape of this data. Now what we want to do is we wanna currently the issue is that the way we're gonna be making this thing is we're gonna have like 3 dimensions in the decoder. So currently we are dealing with 4-dimensional data. So other than that, we're also gonna have one more thing, is that in the decoder, just the layer before, like the reshape layer, we're gonna have like the output layer, and the number of nodes that the output layer should have is gonna be equal to this. So what we need to do is we just say 200 times 200 times 3, and that is gonna be the number of nodes that we want to have in the output layer. Now as you can see, that is a very huge number. It is 100,000, 10,000, 120,000. So this is a very huge number, and this is the problem with data sets like this. Now first of all, 200 by 200 isn't like some crazy good resolution, and even with using this much, the main issue is we are using 3 color channels because we are dealing with data that usually has you know, like colors are very important with data like this, so we can't get rid of colors. So yeah, so I don't even think we will be able to train it on like something without like 2 to 3 GPUs, but we can give it a try. So now we can just specify the latent dimensions. Now the way we're gonna be doing this, alright, so I am actually gonna be using the TensorFlow model, the one that they are using on their website, because it's a pretty good one. And so I just feel like it should work. So we can just define the autoencoder class, and it just takes in that the one thing which is just model, and then we can just define init self and the latent dimensions. Alright, cool. And now we're going to be creating the first we're going to be creating the autoencoder, and then we're going to be creating the decoder. So let's just do that. So first we are just going to do like your basic boilerplate. So we can just say autoencoder comma self dot underscore init underscore. Perfect. Alright, then we can then just say self dot latent dem is equals to latent dem. Alright, so now we can create the actual encoder. So self dot encoder is equals to keras dot sequential. We're always gonna be having a sequential model. Then we can then just say keras dot layers. Now the way we are gonna have is we're gonna have a, now initially I was thinking that we would have like some dense layer, and then we would have this, but now that I'm looking at this entire thing, I feel like we can't do anything, because if we are loading this in at 200 by 200, I really can't do anything. So I think what we're gonna do is we are going to have to make major cutbacks on our data loading, because if we don't do that, it is never going to work. Like I don't think, I literally feel like the GPU that can do this would be costing like thousands of dollars, and I can't spend that on this video. So yeah, we're gonna have to do it at a much lower resolution, because we can't do it at 200. Because I think you kind of get it why we can't do it. We got it, like you can't have 120,000 nodes in like the last layer of autoencoder class. So like the best way to really do this is to kind of cheap out on the file dimension. Now obviously if you are running like, I don't know, like some crazy like 100 gigabytes of RAM and a few A100 chips or something like that, then surely you can actually run this on your machine really nicely. Like it will actually run very quickly, but unfortunately neither me nor Kaggle does it, so I can't really do anything like that. Surely, if again, if you have the computing power, you can surely go at 200 by 200. 200 by 200 isn't a great resolution, but for neural network, that's a gold standard, I'm pretty sure. At least for something like this, I'm pretty sure like your neural network will do very nicely. But again, it's not feasible in any way possible, so we really can't do that. So I am just gonna say 30 by 30, and as you can see, it greatly reduces the number of nodes that we need. Like initially we needed 120,000 and we reduced it to 2700, so that's pretty neat. So that should greatly reduce our processing time, and it should also allow us to maybe add a few layers later on in the decoder. So we are just gonna create a flattened layer over here, like because we can have a dense layer now. So we can then just say keras dot layers dot dense, and this one will just have the latent dimensions and an activation of the rectified linear unit. If you don't know what activation functions are and stuff, it's pretty simple. There are a bunch of really good resources out there, you can check them out. So we can just say keras.sequential. Now this one will be a little different. This is going to be a little more complicated than the encoder. The encoder was like super simple. Oops. Alright, cool. Alright, so this is gonna have a keras.layers.dense. Now I probably should be providing something else, but I'm not gonna do that for now. We can just do 2700 activation sigmoid. So this should hopefully act as a pretty neat little output layer, and then we can just pass in it to a reshape layer, so we can actually display that. And then over here you're just gonna have to pass in 30 by 30 by 3. It should basically match this. Alright, you can't pass in anything else or you will get an error. Model is not defined. Oh yeah, you actually gotta import that from here. Alright, so I'm just gonna quickly import that from tensorflow dot keras dot model